What?
I have a bunch of work papers. Like, I don't know why. Because all mine I turned in, like I have chapter 5 exercises, 6.2, chapter 6 exercises, chapter 6 practice quiz. All just in my folder.
Well, there was a good chunk of class where we were, well, all the snow days, right? We were at home, so I wonder if that's what it was.
And you might have been.
I need you to go ahead and download your 3.2.5 notes. This is an in-between section that I've added to go with today's worksheet. We've already done the yarn. You guys did that yesterday, and I'm glad I did, considering there are several students that are quarantined. It's always fun when everyone's here, but I guess we've already done this part. If I would have looked ahead, I looked, I was like, why did I not put that? Remember I said yesterday we needed to write in our notes what the triangle inequality theorem was? I kept asking myself, why is that not in here? Well, it's because it's in these notes. Yesterday's homework was all about the angles of a triangle. So yesterday we talked about the triangle sum theorem, which says there's 180 degrees if you add up the 3 interior angles. We also talked about the triangle exterior angle theorem, which says the exterior angle of a triangle is equal to the sum of the 2 non-adjacent interior angles, aka that angle is the sum of these two. Okay, so we use that a lot. If you can solve equations, you were probably in good shape for yesterday's 3.2 homework. Well, tonight's homework's not on big ideas. It is a worksheet. And so to get you ready for the worksheet, we're going to take some notes for the first half of class, and then I'll get you guys started on the worksheet. So we've already done the yarn. We've already done this part. We'll move on to this section. Triangles can be classified by their angles and by their sides. We talked about this when we did our review test, our 7th grade review test on Monday. Yes, Caitlin.
Do you have paper copies of the worksheet?
Do I have what?
Paper copies?
I do have paper copies. Yeah, everyone will get a paper copy here as soon as we finish the notes. So if I'm classifying triangles by their angles, there's 3 different ways I can classify them. I have acute triangles, which have 3 acute angles. I've got right triangles that have 1 right angle and 2 acute angles. And then I have obtuse triangles that have 1 obtuse angle and 2 acute angles. So every triangle is going to have at least 2 acute angles. So just because you see that it has an acute angle does not mean that it's an acute triangle. They all 3 would have to have acute measurements in order for it to be an acute triangle. Okay? Because even an obtuse triangle has 2 acute angles. Dylan?
I'm sorry, I didn't see the 2 like things.
That would be angles and sides. Yep. So triangles can be classified by their angles and sides. So again, yesterday's big ideas homework was all about the angles. It didn't even ask you what to classify them by their angles. It just wanted you to find missing measurements. So today we'll do a little bit of both. To classify triangles by their sides, we have equilateral triangles that have 3 congruent sides and therefore 3 congruent angles. You'll always have as many congruent sides as you have congruent angles. Okay, there's a relationship there with triangles. If it's isosceles, it'll have 2 congruent sides and 2 congruent angles. And if it's scalene, it has no congruent or 0 congruent sides or angles. They're all different measurements.
I'm gonna forget.
Yes, I wanted to make sure. The reason this is here is because I've had students kind of complain like, oh, I'd forgotten those. Since I said, well, we'll make sure we get these covered for next year. So the reason you guys are taking notes today is because there wasn't a section of notes. The book just assumes you remembered all this stuff. And I know that, you know, it's hard to remember all this stuff, but these are more definitions. So add these to the definitions we've already got, and your definition list for this chapter is growing rapidly. We talked about congruent angles, alternate interior angle, not congruent, corresponding angles, alternate interior angles, alternate exterior angles, vertical angles, complementary angles, supplementary angles, adjacent angles, isosceles, scalene, equilateral, acute, obtuse, right, straight angles. What else have we talked about? Triangle sum theorem, triangle exterior angle theorem, triangle inequality theorem, which I will write down here again. I think it's the next one up. Yeah, we'll get there in a second. So is our list of chapter 3 vocab words just keeps growing. And they're not all even words. Some of them are just ideas, like the idea that there's 180 degrees in a triangle. All right, so let's classify these triangles by their angles and by their sides. Caleb York, let's do the angles first. Is this an acute, right, or obtuse triangle? It is obtuse. It has one obtuse angle, and it's isosceles, which spells a little bit weird. It's ISOSCELES, isosceles, even though you don't pronounce it that way. Riley, what about example B? It is equilateral. How would I classify it by its angles? Good. Yep. If it's equilateral, it has to be acute because, as we've mentioned already, if you take 180 degrees and divide it by 3 equal sized angles, you're going to get 60 degrees. So they're all acute angles. So it's acute equilateral. Is it? I think, is it?
Yes.
IL, yeah. You could also say that it's equiangular.
Yeah, I was about to say, I remember last year, I think Mr. Covery said there's such thing as equilateral, equiangular.
Yep.
I don't know.
Because all 3 sides are equal, all 3 angles will also be equal. So every equilateral triangle is also equiangular, and every equiangular triangle also has to be equilateral. Okay, and they're all 60 degrees. They're all acute, and so I could take either one of those. Okay. So you could say it's acute equilateral. You could say it's equiangular equilateral. I'll get the idea. And then what about example C, AJ? Yes, it has a right angle, and since they didn't use any of the red tick marks to show any sides being the same, then this would have to be scalene. So that's how you classify triangles, by their angles and by their sides. Okay. So I want you to remember for a second the frustration of the 2 groups that weren't able to make a triangle yesterday. Okay, with the yarn, unless of course you overlapped it, which was not allowed. Not every 3 sides can form a triangle. And so we talked about the triangle inequality theorem, not to be confused with the triangle sum theorem, which says there's always 180 degrees when you add the 3 interior angles. But the triangle inequality theorem states that the sum of the lengths of any 2 sides of a triangle has to be greater than, there's your inequality symbol, greater than the length of the 3rd side. So the only time this comes into play is it's when you're looking at the 2 shorter sides. Okay. Obviously, the long side and a short side is going to add up to be greater than a short side. So the only time this comes into play is when you have 2 short sides that don't add up to be longer than your longest side. Even if it's equal to the longest side, it will not work. It's got to be greater than, not greater than or equal to. Okay. So if it's, you see here, 4 plus 2, that equals 6. That's greater than 5. So that's going to make a triangle. Over here, 2 plus 2 is 4. That's not greater than 5. So that's not going to make a triangle here. And this is the case of when they're equal. 3 plus 2 is 5. The only times these black lines will touch is when they're overlapping with the base of that triangle that's already there. And so that doesn't form a triangle. It just makes a really thick line. And so that's not equal to. We don't want it to be equal to. We want it to be greater than. So on tonight's worksheet, I'm going to show you the work that I need to see in order for you to prove to me that it passes the triangle inequality theorem. You're going to take the 2 shorter sides of your triangle. You're going to add them together like this, 5 plus 10, and you're going to say it has to be greater than 20. You are then going to simplify. Levi, what is 5 plus 10? Levi, is 15 greater than 20? No. Will this make a triangle? No. Okay. It will not. Yes, Dylan.
You put like the little line like through the
like this, you mean?
Yeah.
You could. I'm not going to require it as long as you have the word no there. So you're saying 15, you basically the no is saying 15 is not greater than 20. That's not true. So it's not going to make a triangle. New check.
Can you simplify, like, going like both ways?
I would prefer you not. I want to make sure, I want to see the two sides you're adding together. Nuche is saying, can I just write 15 is not greater than 20? My answer would be no, I want you to actually write the 5 and the 10. So I make sure you're adding the two appropriate sides together. Riley. Okay, Riley, what are my two short sides?
4.
Okay. And that has to be greater than 6. Riley, is 4 plus 4 greater than 6?
Yes.
Yes, because 4 plus 4 is 8. 8 is greater than 6. So I put a yes right there. This is a triangle. I'll go one step farther. What kind of triangle is it? Ashton? Sorry, I don't have time to wait. Riley? It would be isosceles.
Is that required?
No, it's just going to ask you if it's a triangle. Now, what kind of triangle was this one? Trick question. It wasn't a triangle. It's not one at all. They don't match. They don't meet up. So it's not a triangle. Oh, it would be scalene if it were a triangle. Caitlin. Yes. Did you have a question, Riley, though? Yes.
So I have seen, when I've seen people do it a certain way, where they look at the two, they look and see if there's two sides that are equal to each other, because I don't think it's right, but I see people do that a lot.
That won't work. If you're trying to see if two sides equal a third side, if that's true, it still doesn't make a triangle though. It has to be larger. Okay, it's not the triangle equality theorem, but the triangle inequality theorem. So remember, inequality means it can't be equal. They've got to be greater. Okay, so if you've seen someone doing that, they're either doing it wrong or maybe they're doing it for a different type of problem. Caitlin, example C, go ahead. And what are my two smaller sides? Oh, good. I was hoping I wouldn't trick somebody on this. Maybe I did. 1.5 plus 0.5. They didn't put them in order from least to greatest, and they don't have to. That has to be greater than 2. So Caitlin, what is 1.5 plus 0.5? 2. Is 2 greater than 2, Caitlin? Yep. So this is just going to make a really thick line. It's not really a triangle. Okay. Devin, what would I do for this one?
10 plus 10 is greater than 10.
Yeah, there isn't a short side. So again, I just add the two of them together because they're all the same. What is 10 plus 10?
20.
Okay. So what I'm showing you here is the exact same amount of work I'd want to see on your worksheet. It's not much work. And then you said triangle, yes or no?
Yes.
Yes. In fact, what kind of triangle is it, Devin?
Equilateral.
Yes. Do I know what the angle measures are of this equilateral triangle?
Yeah.
Yes, because if it's equilateral, it's also equiangular, and they're all going to be 60 degrees. Do I know what the angle measures are of this isosceles triangle? No, not without more information. I know 2 of them will be the same, but I don't know what the third one is, the obtuse angle, or maybe it's not even obtuse. It could just be slightly larger, but I don't know enough information about it. Okay, this one really challenges you. This one's going to take the inequality theorem to the next level. And so in order to figure out what values X could be in order to make this a triangle, I'm going to be showing the same work that I did before, which is adding my 2 short sides together to see if it's greater than my long side. So the 2 short sides in this triangle are the 2-inch side and the X-inch side. And I know, bless you, in order to make a triangle, that has to be greater than the longest side. So I can solve this, right? Before I was just simplifying 10 and 10 to make 20 to see if it was true. Here I'm solving. So Madison, what do I do to solve for X? Excellent. So X has to be greater than 4. Okay. So if X has to be greater than 4, I'm going to put 4 right there. If 4 is the minimum value, right? X has to be larger than that. What does X have to be smaller than? Devin?
6.
6. Because if X is larger than 6, it's no longer qualifying as a short side, right? It said it was the short side. So it's got to be smaller than 6. In fact, I would even say you could put an equal sign underneath that, because if it's equal 6, I'd say you're okay. It just can't be larger than 6, because then it's not the long, then it would be the long side, and we already know it can't be. X has to be a short side. Riley.
So if X were the long side, if you write 6 plus 2 is 6 is greater than X, then X can be any number under 8.
You're onto something. In fact, can we just look at the next one? The next one actually had that same question where X is the long side. So the two short sides have to add up to be greater than the long side, as Riley was just saying. Riley, what's 21 plus 14? 35. So X has to be less than 35. 35. Another way of saying 35 has to be greater than X. So if X has to be less than 35, 35 becomes a maximum number, which goes right there. So what do I put here, Dylan?
The text isn't very easily visible.
Oh, I'm sorry.
Also,
There we go. Also what?
X has to be greater than.
AJ, what do you think? Why? You're right. Yeah, X has to be larger than 21, because if X is smaller than 21, 21 now elevates to the long side, and that's not the case in this triangle. Okay, so X would have to be between 21 and 35 in order for that triangle to work. If it's longer than 35, then the two short sides won't meet up, because they'll be stuck. It'll be like this. You're like my long side right here represented by my arms, and then my two flippers not meeting up, right? That's what happens when you don't pass the triangle inequality theorem. You don't have a triangle at all. And then a unique triangle, you're going to see that on the worksheet. If it asks you if it's a unique triangle, the definition of a unique triangle says it has no equivalent, which means there is no other triangle with the same dimensions and shape. It's one of a kind. And so if you get a question where it says, how many triangles could you form with these dimensions? How many different triangles could you form? The answer is either going to be, you could form many triangles, you could form one triangle, which means it's unique, or possibly no triangle at all. We just looked at a couple of questions where if it said, if I said how many triangles could I form with those dimensions, you would say none, right? If I said how many triangles could you form with these dimensions, would you say one or many?
Many. One.
All right. So think about what I'd be allowed to change.
They'd be different, right? Like different sides. Like if 2, 4, if there were any other number, they'd be different. So wouldn't there be 2 you can make?
Well, if I gave you a 4 centimeter side, if we were to get a ruler and cut out 4 centimeters, okay, I'd cut out another 4 centimeter side, or the yarn, right? And then a 6 centimeter one. When you connect them, when they connect, that would be the only triangle that they form. Because think about it, the only way you can make that triangle different is by expanding and making it bigger. But if you make it bigger or smaller, you're changing the side lengths.
Because I was gonna say you could just like, if you made the yard 2, 4, you could just switch the 4 and it'd be technically different.
What you're doing is you're rotating it. Rotating it does not change the triangle. It just changes how you perceive it. Okay. So then the question is, well, okay, what if I don't change the sides, but I change the angles? Because that would result in a different triangle. But here's the thing. If I widen out one of the angles, it's going to make one of the sides longer, right? So if the sides are locked in, side, 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 then I can only make one of them. Okay. So underneath unique triangle, I want you to write in SSS. If you have the 3 sides of a triangle, it is unique. Because you can't change any of the sides. They've already given you 3 of them. They're locked in. And you also can't change any of the angles, because if you widen one of the angles or make it a little bit skinnier, it's going to change one of the opposite side. right? Whatever one is across from the angle you're changing. So I can't do that. So it's unique. Okay. There's one more I want you to write down. SAS, side angle side, or SAS. Like Brent Sass, who's currently leading in the Iditarod, I think, or at least he was this morning when I looked it up at
Yeah.
7:30.
But the other guy said it's pretty.
Ah, so Brent hasn't done that yet? So eventually he's gonna have to. Okay, so if you have two sides and the angle between those two sides, it is unique. So if I said that you had let's say two 5-inch sides that met at a 90-degree angle. We'll just make it easy to draw a right angle. Okay, so I've got a 5-inch side here and a 5-inch side here, meeting at a right angle. Well, yeah, I don't have all three sides, but I have two sides and I have the angle between them. And what happens is when you lock in the angle between those two sides, you've also then locked in that third side. Yeah, all I can do is literally just connect it. I can't make this blue line any longer because it makes it an obtuse triangle now. I can't make it any shorter because it makes it an acute triangle and it changes this angle. So even if you don't have all three sides, but you have an angle between two, you've locked it in and that triangle is now unique. Now, if I had a side-side angle, not to be confused with the angle side-side, we don't write that one, okay? We don't do angle side-side. We just do side-side angle. You guys got that? Okay. It's okay. No, but seriously, they don't write that one because of that. So let's say I had side-side angle. So I knew this was going to be, we'll say 3 inches. This was going to be 7 inches. And I knew that this angle here had to be 45 degrees.
But you would just control the line.
Yeah, I mean, that angle's got to be 45 degrees. But
If they have to.
it never said what this one had to be, right?
Oh,
So I could make this one obtuse. I could make this a right triangle and still keep that on 45 degrees, right? I can still make it 7 long and 3. So I could make many different triangles out of that. I could make many different triangles out of that. So it's only when you have the side, 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 or the side angle side. Now, what you might be thinking, what if I have angle, angle, angle? What if you lock in all 3 of my angles? No. I have a 45 degree, 90 right triangle, okay? I never said what any of the sides had to be, correct?
yeah, they could do this.
Okay, so watch this. Do I still have a 45 degree
Yeah.
right triangle?
Yeah.
Yes, and I've made the sides all proportionally longer, right? I've dilated it, I've enlarged it. It's similar, which means it's not the same, right? Congruent meant it was the same. But if I have a similar triangle, it's 2 different triangles. And so even if I lock in the 3 angles, I could still make many triangles with those. Just keep making it bigger and bigger and bigger and bigger, or smaller, smaller, and smaller. AJ. 2 angles in a side. Angle, side, angle.
So when you say like angle, side angle, or AAA or SSA, is that the order you're giving them in?
Yes. On this one, I
I figured it would be 1. But you can't make that 2.
I think you're right. I think there is a third one. I think you got it, AJ, because if I can't change the 10. right? Because the side in between the two angles is given. If I was, let's just say this is a right angle, I could make this line however long I want, but by making this line longer and shorter, it then would have to change this angle.
Yeah.
So I think we can add a third one in. I don't know if it shows up on your worksheet, but I'll go ahead and add it in. I'll have to double check
Oh,
for
I've
you.
been adding all of these.
No, don't add all.
Okay.
So I think if we have an angle, side angle, we may have forced the triangle's hand in order to make it look a certain way. Because if I make this line shorter and say, let's say I'm going to say, well, I'll just make you go here. Well, then I'm changing this angle degree from 40 to 50, and so that one, but it can't change. So I think that we're looking at a unique triangle here if you have the angle, side, and angle. Like I said, I don't know if there's one like that on the worksheet, so I want to make sure I covered the two that I knew were. I'll see if there's any more. While you guys are working on your worksheet, I'll see if there's any more. Your worksheet, by the way, let me pull it up real quick. By the way,
Do you have anything?
I have tons of paper copies of it. Your worksheet, the triangle worksheet. Find it here.
It's the third one from the bottom.
Oh, okay. I think that's the key. Is that the key? No, we must have just done it together. Okay, well, never mind. Let me erase it. We'll talk about it in a second. Let me go ahead and get your paper copies to you. Oh, I guess I can stop recording too. So don't listen.
Do we have to do our paper?
Have you already started on the